Hi everyone, it's Miss Herman. I would say just about everything with this assignment did not go according to plan. So I'm making this little video to do all the things that we didn't have a chance to do in class. My goal was that we would talk about this and kind of work it out and kind of think about it, and then the math would pop out, which is pretty much what happened. But then we didn't have time to talk about this column or any of this question or any of this question, so I'm guessing that you probably need some guidance. So what I'm going to do is talk my way through all of these things. You're going to watch the video so that you know exactly what's going on. And then on our next assignment, you should be ready to use your notes to complete things independently. Are we ready? Okay. So here we have our automobile. It's accelerating at 2 miles per hour every 5 seconds. We're assuming it's starting at 0 miles an hour, like it's starting from rest, and it's going to keep going. And it's going to keep accelerating for 2 minutes at that rate, this rate. So now we want to know, how fast will it be going in 2 minutes? When we talked about this in class, we said, well, we could make a table. So after 5 seconds, it's going to be going 2 miles per hour. Great, because that's how fast it's going. And then after 10 seconds, it would be going 4 miles an hour. And if we just kept following this table, eventually we would get to a point that had 120 seconds, also known as 2 minutes, and we would have a speed. All right, that's what I did. So I made myself a little table, and I just kept going 5, 10, 15, 20, and I went all the way down until I got to 120. And then I went to 4, 6, 8, 10, and I kept going until I got to 48. So I have my answer, 48 miles per hour. Now, there's got to be a better way to do this, because I don't want to have to make a really big table every time I want to solve a problem like this. There was some math that we thought about. So at one point, people said, oh, we should divide by 5. Why should we divide by 5? It comes out with this number. What does that mean? I'm calling that 24 intervals. So what we know is that I'm going up by 5s as I go up here. And so the question is, how long does it take me to go from 5 to 120? So if I count how many intervals I have here, it turns out there's 24 intervals. Likewise, this number is going up by 2 every time. And that's how many intervals? 24 intervals. So if I take 24 times 2, I end up with that same number. It turns out this isn't magic. I mean, it kind of feels like magic. I take 120, I divide by 5, multiply by 2, that's what I get. Well, acceleration is this ratio. And it's a ratio of every 5 seconds, I'm going 2 miles an hour faster. And so what I'm doing is I want to know in 120 seconds, how fast will I be going? So this might be familiar from your math classes. This is a proportion. So my question is, if I'm going 2 miles an hour faster every 5 seconds, how fast will I be going in 120 seconds? What would I do to solve this? I don't know how you've been taught math in Mrs. Carr's or Mrs. Clymer's class, but in this case, this is a proportion. So I'm going to take 120 and multiply it by 2. And the cross multiply and divide method, maybe you've seen that. But also I can think about this. What am I changing it to go from 5 to 120 and then from 2 to x? And this is where we got that 20 divided by 5, right? I know that I multiply by 24 to get there. Or to go the other way, I divide by 24. I divide by 5, I get 24. So I know that this proportion is going up by 24. So that's why that works. Because what's happening is I have equal fractions. And so if this ratio is going to be the same, I have to multiply the top and the bottom by the same amount. So that's one reason why that happens. The other reason why that happens has to do with our definition of acceleration. Acceleration has to do with the change in velocity over the change in time. So I know what my acceleration is. I know my acceleration is 2 miles per hour every 5 seconds. I know my change in velocity is going to be something, I don't know what, and the time is 120 seconds. So again, I've set up that same proportion. to find out what the velocity is going to be after 120 seconds. In class, what we did was we took 2 divided by 5. So I took 2 divided by 5. And then I multiplied by 120. And there you see that same operation again, right? 120 divided by 5, 120 divided by 5. And then multiply by 2 times 2. And I get 48 miles an hour. So this is really great. We've done this problem 3 different ways and we've gotten the same answer every time. Awesome. Distance. I'm going to put that off to another time. Let's talk about this while we still understand some of it. Hang on. I have another piece of paper here. All right. So here I have a situation. I have, they're talking about a race car. Leaves as the pit stop after refueling stop and accelerates uniformly, great, to this speed. So it's starting at 0 miles an hour and ending at 75 miles an hour. And it does that in 9 seconds. The question is, what is the car's acceleration? Well, acceleration, and actually this is in, look, I even put this in here for you. So acceleration is on the first page of our document, but it says change in velocity over change in time. Do I know what the velocity change is? Yes. I went from 0 to 75 meters per second. Do I know what the time is? Yes. It's 9 seconds. This problem's actually easier than the problem before. Because here, I have the velocity, I have the time, I want to find out the acceleration. Before, I had the acceleration and I had the time, and I wanted to find out velocity. And actually, we didn't even have acceleration. We had some other numbers that were confusing. All right. So I should be able to do this. I have 75 meters per second is the velocity, and I have 9 seconds is the time. So I should just be able to take 75 meters per second divided by 9 seconds. And I didn't actually calculate this. It's 8 something. 8 3/9, right? 72, 8.3 meters per second per second. Okay, I feel like that's the right answer. You can do it on your calculator and tell me if I'm right. All right, so now what it says is, what was the car's average speed? Well, the average speed is the change. Wait, that's not it. Oh, I'm skipping that one. I thought I had that fit in my head. Oh, Miss Herman, you're so much fun. We're skipping that too. We're going to go on to the next easy problem, and then I'm going to do a different video for the hard stuff. All right. Oh, it's just like you're with me live. All right, here we are. D. So a second car does the same thing. It leaves its pit stop. It goes also to 75 miles an hour, but it does it in 8 seconds. So think about this. The same change in speed, the same time. Which one is accelerating more? Which one has the higher acceleration? Yes, this one, because it got there faster. So let's find out, what is its acceleration? So here I'm going to take 75 meters per second divided by 8 seconds. And again, did I get a calculator? No. But I know that 8 times 9 is 72. So this is 9, which leaves me with 3/8, which I think is 0.375. I don't know. I'll look it up. Meters per second per second. All right, that's way too accurate. Since I only have one decimal place here, I'm going to round this to 9.4 meters per second per second. Another thing, this is just some units action. So here's a little side note about units. Typically, when we write units for acceleration, it is meters per second because I'm changing the velocity every second. So every second, I'm going 9.4 meters per second faster. When we write this in notation, it has this really weird notation. It actually makes sense mathematically, but not practically. We usually write this as meters per second squared because it's meters per second. So both of those S's are on the bottom, second squared. So this makes sense mathematically. If you were to reduce a complex fraction with variables, it would be this. But it doesn't really make sense. Like, what's a square second? Like, I know what a square meter is. It's a meter by a meter. But I don't know what a square second is. Like, I can't go a second in this direction and then a second perpendicular and get a square. Like, what does that? It doesn't mean anything. This is just a notation. All right, I'm going to go on to the last easy problem before I get onto the harder ones. All right, let's take a look at 13. Here we go. I have an aircraft carrier, or a jet, is going from 0 to 250 miles per hour in 30 seconds. What's the jet's acceleration? All right, we've done these a bit. I think we know now, right? We did it here. Wait, let me get that on the screen. We did it here. We did it here. So do I have the change in velocity? Yes, it went from 0 to 250 miles an hour. How long did it take? 30 seconds. So I can find the acceleration. Acceleration equals 250 miles per hour in 30 seconds. Ms. Herman, did you grab your calculator this time? No, I did not. This is going to be 8, 200. Oh, yeah. Yeah, let's do some real division here, Ms. Herman. Yeah, 24. That'll be 10. So a third, so 0.3 meters per, no, sorry, this is miles. Miles per hour per second. Cool. Then on A, it says, if after takeoff, the jet continues to accelerate at the same rate for another 15 seconds, how fast will it be going in that time? There's a few different ways to do this problem. One way to do this problem is you could make a table, right? Just like we did on the previous problem, right? Where we made a big table. You could make a table and say, well, I know it goes from 0 to 250. Wait, 0 to 250 in 30 seconds. So I could say, all right, well, in 15 seconds, it's going to go here, and then another 15 seconds at 45 seconds, right? I could figure out what this number is in half, and so I could do it with a table like we did before. If you're confused about that, don't worry about it. Or I can do it the same way. I know it's going to accelerate at the same rate, so I can do it this way, where I say, well, I know what it is in this amount of time. How much is it in the new time, right? So I could set up a proportion the same way, where it has 250 miles per hour in 30 seconds. How much will it be going in another 45 seconds? Or I'm sorry, in another 15 seconds, altogether 45 seconds, right? And I could solve my proportion that way. So that's another way I can do it. And then, look, we have another question about distance. We had another question, how far does the race car go about distance? How far does it go about distance? That warrants its own video. So I'm going to worry about that later. Oh, see, I forgot this one. How much time does it take for it to reach 500 miles an hour? Well, check this out. We can do it the same way we've been doing it. In this case, I know it goes 250 miles per hour in 30 seconds. It gets up to that speed that fast. So now in this case, the question is, how much time? So this is what I want to know. I want to know how long it takes to get there. And what's my speed? 500 miles per hour. So since I'm able to get up to 250 miles per hour in 30 seconds, I should be able to get up to 500 miles an hour in 60 seconds or 1 minute. Right? This is times 2. This is times 2. So it'll be 60 seconds. Ms. Herman, are you going to solve this problem? I could, but I can't do it in my head. I don't have a calculator. But I know it's 8.3 times 45. Yeah, you can do that on your calculator at home.